Hi everyone. Thanks a lot to Camunda for allowing me to give this feedback to you. Who am I? To come here today to speak to you. I'm the CTO of a company called Quicksign. We do digital onboarding. I've been in this company since 2014, so it's around 4 to 5 years. Before that, I was a consultant for 9 years in a French consulting company. And I've been designing enterprise architecture for quite some time now. I've joined Quicksign to help them in everything tech related, obviously. Who are we? So Quicksign is one of Europe's leaders in digital onboarding for financial services. We now handle millions of financial transactions per year, which wouldn't seem that much compared to other industries, but in terms of financial transactions, it's actually quite a lot. We are not very well known from the general public because our solution is actually used under the hood by big companies like banks, insurances, but we are always integrated in white label, so you as a customer will never see us. So, which is one of the reasons why I'm here today. It's to give a bit of visibility to what we do at Quicksign, to engineers and you as an end user. We provide KYC, OCR, and electronic signature features with customized workflows, and our objective is to drive back office integration using OCR and optimize operational efficiency in insurances and banks during the end user onboarding process, because onboarding new customers is obviously very important for a lot of industries, so that process is very important to optimize. We've been doing that for 10 years. We are in 15 countries, and we have a kind of a good growth rate in terms of the number of transactions that we handle on the platform. Each year we handle 70% more than the year before. So the pressure on our platform is growing quite a bit. So as I said, we are used by many banks and insurance companies and also retail industries. Those are one of the key customers that use our platform. We have BNP, HSBC, ING, Orange Bank for one of the latest ones. We are well known, but we are actually used by important industries. Why change anything? I mean, we've been doing this for 10 years. It's working good. Our growth is sustained. So why would we want to change anything? Well, our platform has gotten too hard to maneuver. It's too heavy. It works, but it's been built around an in-house workflow by configuration engine. I mean, like many companies in our field, I guess. And it has gotten to the point where changing anything is too complicated. It's a monolith. So we had gotten to the point where we had to change something. It's too hard to scale. It wasn't designed for that at the beginning. It wasn't designed to be multi-tenant. So adding multi-tenancy to a platform which wasn't built for that since the beginning is quite a challenge. Well, and we took too much time on fixing defects, and it was frustrating. So we had to change this. What did we need? Well, decrease time to market. I mean, who doesn't want that? I think everything in this room wants that, to ship products faster. So that's no new no news. Scale in technical terms, but also in business terms, because okay, we have a sustained growing rate, so we want to be able to handle more transactions on our platform, but we also want to scale as a business from a business standpoint. What does that mean? On the markets on which we are currently already implemented, such as France, Germany, Italy, well, our customers have ever-changing needs. They want to optimize their processes. They want more efficiency, and rightfully so. That's why they use our platform. But we also want to get into new countries, new local markets where the laws are different, and we need to be able to adapt to local legislation, which is very different from a country to another. Innovate faster, add more features. I mean, we have a kick-ass data science team. We do all the latest fancy stuff, and we had very nice new features, but it isn't useful if you cannot get your new data science feature into your product. So integrating those features into the product was very important for us. As a tiny indication of how hard it is, the very first data science feature that we developed in our lab took 1 year to end up in our product. It was before we changed the platform. Today we don't want 1 year, I mean we want a week. And with the new platform it's possible, even less. More agility. We've tackled the problem at the methodology level. I mean, using agile methodologies such as Scrum derivations, but it's useless to do. I mean, it's my point of view, and not everyone has that point of view. But my point of view is that if you can be as agile as you want from a methodological point of view. If you are driving a tanker, you will not go faster. You will not turn faster. So you need to be agile at the core technological level. So, yeah, we also needed various other steps, such as auditability, multi-tenancy, security and resiliency by design, and cut operational cost and complexity. I mean, our previous platform is kind of costly and complicated to operate, and we didn't want that anymore. And fun to work with. I mean, we're a tech company. We are mostly engineers. The product that we develop, we work on it every day, and we want to be able to have fun working on it and not suffer. So we decided to go BPMN-centric. By having all our features revolving, being orchestrated by a BPMN engine, such as smart document management. I mean, we are in the digital subscription business, so one of the core features that we have is collecting your personal information and your personal documents. So that's one important area. Electronic signature, we sign contracts. Traceability, we are in a very... somebody gave me the word during the lunch and I forgot it. But compliance, thank you. We are in a very compliance-oriented market. So we need full, thank you, traceability. Yeah, more light. AI, I mean, we are doing a lot of AI-oriented features, statistics and KYC, know your customer, whatever. Also, microservices, a key point in getting agility. So, what did we do? I've talked about the motivations. Now, how did we tackle the problem? With what is called Kappa CQRS-ES architecture. That's kind of complicated acronym, but I won't go too much into the details. I try to keep it as an overview, but enough so that you get the point. So we have a REST API. One of the key things is that we separate the writes from the reads. And on the write side, we call Camunda, using its out-of-the-box REST-HATEOAS API. And the Camunda engine, depending on the process definition that is deployed, calls various of our features, such as our OCR engine, our fraud detection engine, or our signature engine, or third-party services, because we also integrate a lot of third-party services. All those services, whether they are internally developed at Quicksign or externally available, are integrated in our platform as microservices. And they can also, they can be either synchronous, you call them, they give a reply, which is a bit different from what was mentioned earlier with external tasks, or they can be asynchronous, and in Camunda you can implement asynchronously either with external tasks, but there are various ways. External tasks are one, but we didn't go that way for various reasons. We instead chose a bus-oriented approach using Kafka, because we need full traceability. So I understand for many use cases, external tasks are much easier and you should go for it, but we needed to actually trace everything going on our platform, which is why we chose to go through Kafka. And here comes the interesting part, which is kind of particular on our architecture, is that we don't go through Camunda for reads. We go through Camunda only for writes. For the reads, we leverage the history API, which is available out of the box in Camunda, and we have done our own implementation of that SPI, which sends each and every tiny BPMN events to a Kafka topic, which we call internally the history stream. It's an append-only immutable logs, which means that you never modify it. You only add to it, and you can consume it from as many microservices as you want and as many times as you want, which gives extreme flexibility and a lot of very interesting properties. We consume, it's one of the backbones of our architecture. We consume that history stream for many microservices, but I won't go into every one of them, obviously. The two main ones are the case microservices and the search microservice. The search is kind of common nowadays. We consume those events and we index them in Elasticsearch in order to have full text search features. There is in the Camunda community a plugin which does exactly that, but requires to be deployed inside Camunda, which we didn't want. We wanted the Camunda engine to be the Camunda microservice, as lightweight as possible, and to move all the weight, all the load to other microservices that we could scale independently. And as we needed anyway to have that history stream for traceability and to add as many microservices as we wanted, we could as well index from that same topic. The other microservice, which is original, is the case microservice. It's the one who has a responsibility to create a JSON representation of our case. We read all those tiny events and we create a business-oriented JSON representation who contains the state and the actions. Camunda has such a feature out of the box, but the Camunda feature is for internal use. I mean, it's complete, you can do whatever you want, interact in any way you want with the Camunda engine, but we needed our own business-oriented representation of the cases. I will go into some details after. And the blobs, the binary content. We don't store them either in Camunda or in Kafka. You should not do that, absolutely not. So at the entry point of our platform, we catch the strings, we catch the HTTP when in the HTTP request, we catch all the content which is binary, usually it's multi-part, but not only. And we intercept it and send it to a blob store. And instead of sending blobs to Camunda or Kafka, we send URLs. I mean, it's pretty obvious, but it's something you have to have in mind in the microservice platform. Bridging the gap. I mean, how do you? I mean, we had a platform before. I mean, the platform I'm talking you about today is not yet in production. It's going to be in a few months, so we are very close to the end. But the previous platform is still currently running, and we will not do a full replace. I mean, the new platform is going to augment the previous one. So we need a way to integrate them in a seamless fashion. For that, we are lucky. We did the choice a few years back to integrate the CQRS-ES pattern inside our previous monolith, of our current monolith. It was very painful back at the time. We did it for traceability reasons, for compliance reasons. But when we started this project, we were very happy to have done that choice before, because we can just take all the events produced by our monolith, put them in a Kafka topic, and inject them in Camunda. So that Camunda acts as a kind of synchronization mechanism which allows us to augment the capacities of our previous platform with our new platform. And our customers can just use, since in both cases, both our APIs are REST-HATEOAS APIs, and we try to have a compatible way of authenticating. They can use both our legacy API and our new API seamlessly and benefit from new features and old features. And obviously we can call back our previous system using our previous legacy REST API. A reactively generated REST API. Crazy? I don't believe so. It allows something very interesting. One API per customer. Our API is generated, tailored for each customer depending on the specific business process definition of one particular customer, with only the relevant actions. It can be synchronous or asynchronous. Some of our more tech-aware customers want asynchronicity and are able to use a push model using SSC or WebSocket, but some of our other customers don't want that. I mean, they want something simpler. We're using a simple synchronous API. So we are able to do both. It's data model aware, which means that the REST API reflects the schema of the data which is manipulated by our workflow engine. It has airbag, role-based access control and visibility, which means we can control what variables are visible or are not, depending on the role of the users or on the channel. It is multifaceted, which means that on a same process instance, we can have simultaneously a mobile application and a desktop application connected and have the different faces, different view on the same process instance. The other aspect is performance, read performance. It relieves Camunda, it was mentioned this morning, Camunda is awesome, but it's built on a database and JDBC oriented architecture, which has its own limits. I mean, it's blocking, and it limits the scale, the throughput that you can have. This is fine for us for the writes. The amount of writes that we have on our platform is okay with that limitation. But as far as reads are concerned, it was a limitation, it was a problem that we needed to address. So the read side of our architecture is very fast. I mean, it's hard to get faster than that. And we can scale the reads and the writes separately, depending on our load. It's fully non-blocking on the reads. I mean, the writes are blocking because JDBC in Java is blocking, and there is no way around that. But on the reads, we are non-blocking, asynchronous, and decoupled. Everything almost is in Kafka. The commands, the replies, whether they are single or multiple, the events such as the Camunda history, well, only for now, but we intend to be able to generate more events because for now we have built around this Camunda and Kafka architecture mainly our case service, but we intend to build all our future microservices around it. So our future microservices will have to be able to generate events, and we want them to be in Kafka and for Camunda to be able to listen to them and react to them. Queries, for better traceability, we intend to trace queries also in Kafka, but we are not doing it right now yet. We wait to be sure, to be more comfortable with the load of our platform before adding the queries inside it. So for the queries for now, we are using standard RPC. Dynamic service routing, we wanted to be able to decouple the workflow engine from the activities, from the microservices implementations. I have 5 minutes. Instead of coding, and we wanted to be able to change protocol if we wanted to change protocol, data format, going from JSON to, or changing from JSON to Avro or vice versa, using Kafka or using standard RPC or REST, and without redeploying our workflow engine. So we have developed our own service discovery on top of Kubernetes, metadata, and Camel. And we are doing protocol negotiation, content negotiation, and exchange pattern negotiation. Exchange pattern means synchronous or asynchronous, one reply versus multiple replies, etc. It depends on the microservice. And that negotiation is done at service discovery time. And semantic version and routing also. So we have absolutely no activity-specific code deployed inside the Camunda microservice. Everything is discovered. We might get it open source one day if there is interest, because I mean, it solved a problem for us, but we are not sure that the problem is actually of significant enough interest for everybody for us to do the investment of putting it open source. But if there is interest, we will surely do it. Why Camunda? It simply works. It has a very nice web-based BPMN and DMN editors. I mean, it's one of the first that when I tried, I was feeling like, okay, I could actually use it myself, which is not the case for many of the editors out there. It's customizable. We wanted an editor, a modeler, which we could customize and adapt to our own needs. And we have not done it yet, but we have poked it, and we will do it in the near future. It has a robust BPMN engine. I mean, it just works. It's easy to integrate It has a Spring Boot ecosystem, and we are a Java shop, and we love Spring. So integrating Camunda was very easy for us and very natural. The code is easy to integrate, but it's mostly easy to debug, except for the core process virtual machine, which we have put our nose in because we wanted to be sure that we could be able to debug it and fix it in case of problems. The core is quite hard. I will not. What's next? Load test, robustness, performance. Because as I said earlier, we are not yet in production. We will soon be, but we want to make sure that it's performant and it's robust. Production in September, October, around. Fingers crossed. Feature improvements. Study Camunda Optimize. The optimized product is certainly be very interesting for us once we are in production, once we have to optimize our existing workflows. Our priority right now was to have something running in production and which is robust, not to optimize our process right away. So we will study that. gRPC support, migrate to Kubernetes, well that's details, but migrate to Kubernetes CRDs if there are some Kubernetes aware people in the room, they know what I'm talking about. Customize the designer to our specific needs with our activities, with a custom palette. Add a GraphQL API aside our REST-HATEOAS API, and migrate to ZB when the right side of architecture becomes a bottleneck. Honestly, I don't know exactly when it's gonna get to be a bottleneck, but we know that whenever it becomes one, we can study ZB.